Okay, Rana, good morning. Today we are discussing scanning electron microscopy. So earlier class we discussed synthesis of nanoparticles and their properties. So the synthesized nanoparticles are characterized by the X-ray diffraction method, that is XRD, scanning electron microscopy, and transition electron microscopy, SEM and TEM. So these are the methods nowadays using characterization of synthesized nanoparticles. So let's see the principle of scanning electron microscopy. So what is the principle for the working of scanning electron microscopy? So scanning electron microscopy is generally called SEM, SEM, SEM. So it is a type of electron microscopy that produce image of a sample by scanning the surface with a focused beam of electrons. You know, the principle of scanning electron microscopy. So scanning electron microscopy is a type of electron microscopy. These electron microscopy that produce image of a sample by scanning the surface with a focused beam of electrons. So electrons will interact with the atoms which present in the sample and produce various signals so that contain information of the sample. So this is the principle for working of scanning electron microscopy. So coming to the instrumentation. So this is the instrumentation of scanning electron microscopy. So in generally electron microscopy, light force is used. So where we using the light force which produce protons. So that's why we are not use light source in the scanning electron microscopy. So we use the electron source. We cannot use light source. In this instrument, we use electron source for electron gun. So this is electron gun, so which produce the electron source. So these are the source of electrons. So it is known as electron beam. So electrons are the source of electron gun which produce the electron beams. Here we used electron source. That why it is called means we are using the electrons in the scanning electron microscopy. Scanning electron microscopy. Scanning means scan just. So we are using electron in the microscope. In the microscope will be used to detect the electron images. So that's why it is called as a scanning electron microscopy. Here the electrons are which produces, these are the electron source are known as electron gun which produce the electrons. These electrons are fall on the in the disc, like a disc-like structure anode. So in the form of electron beam. So these are the electrons. So this is known as a disc-like structure of anode, which is also known as a magnetic coil. So here these are the closed surface area of the disc. So this closed surface area of the disc where the electrons are fall on the surface of the anode in a different directions. In different directions. So these directions are restricted by this closed surface. This is the closed surface which restrict various directions of electrons are moving from electron gun to the anode. So here the hole. So at the center magnetic coil they may having the hole. So in that hole the electrons are allowed. In the hole only the electrons are allowed from passes through the magnetic lens, whereas the electrons followed on with the different directions already discussed. So this like hole, and only they allow and they passes through the magnetic lens. So and when they reaches the magnetic lens, the electrons which move towards to the scanning coils. So these are the scanning coils. So these scanning coils here, these scanning coils and backscattered electron scanning coils, backscattered electron, and these are the secondary electron detectors. So these detectors we use it to detect the image when the electrons are moved to pass and reaches the specimen. So before being we electrons move towards to and reaches the specimen, these scanning coils, backscattered electron and secondary electron were connected into TV scanner. Were connected into TV scanner. So here we study the before the electrons are moving and reaches the specimen, that means sample, whatever it may be sample, the synthesized nanoparticle, this is the synthesized nanoparticle. When the electrons are reaches to the nanoparticles, that is known as a specimen or sample or atom. So here we study the image by these three detectors. So we see the general mechanism before being study the image. So here these are the electrons which passes through the anode, magnetic lens and scanning coils, backscattered detector and secondary electron detectors. So when passes through these electrons according to these component and reaches the specimen, so that is the sample, we synthesize it the nanoparticle sample, so this is known as specimen. Here in the first step, here the absorption takes place. So absorption takes place or reflected takes place, or while reaching the electrons to the specimen, there will be formed as secondary electrons. So three types of possibilities are there when the electrons are reaches the specimen. So one is absorbed, second one is reflected, or the formation of secondary electrons. So here coming to here, the absorption of electrons takes place, which is detected by the scanning coils. So whereas reflected takes place when the electrons are reaches the surface of the atoms or specimen. So there is the backscatter electron detectors. So reflection, they reaches the specimen and they get reflected. So that reflection signals can be detected by using the backscattered electron detector. Where in case they forms any secondary electrons when reaches the atoms. So that secondary electrons can be detected by using the secondary electron detectors. So it is pass upon the specimen. So by using these three detectors, we determine the image of the specimen, whatever it may be, we synthesized nanoparticles. So this is the base plate. So here we put the specimen, that is known as a nanoparticle. When the electrons are passes upon to the specimen, so we using these three electron detectors, we detect the image, shape, size of the nanoparticles. So that is the characterization of nanoparticles by using the scanning electron microscopy. Okay, Nana, is it clear, ma? Nana,
Yes,
anyone?
sir.
Is it clear? Have any
Yes,
doubt?
sir. Aimless, sir.
So next we go for a transition electron microscopy. So transition electron microscopy. So what is the principle which involved in the transition electron microscopy? That is the principle. It is a technique in which a beam of electrons is transferred through a specimen. A beam of electrons which are transferred through a specimen to form an image. So the specimen is ultra thin, so less than 100 nanometers, at a very minute nano level. The formation of specimen is ultra thin, that is the less than 100 nanometers. So that size of specimens can be detected by using the transition electron microscopy. So an image is formed from the interactions of the electrons with the sample as a beam is transmitted through the specimen. So here what is this principle says that the electrons are passed through the specimen. Whenever the electrons reaches the specimen, then we detect the image of the specimen by using the transmission electron microscopy. That is that the electrons are transmitted to the specimen, then only we detect the image of the particle. So here Marx Knoll Ruska in 1931, so he discovered the transition electron microscopy. So he puts a lot of efforts on transition electron microscopy, and they get Nobel Prize in the year 1986 itself. So we see the internal working of transition electron microscopy. So here we using the transition electron microscopy to detect the images of a specimen. So here also the specimen is ultra thin, less than 100 nanometers. So that is a very nano level. So that type of specimens images can be detected by using the transition electron microscopy. So in TEM, here also we cannot use light source. So light source is nothing but emission of photon. Light source is nothing but emission of photon. So here also we cannot use light source. So here also we are using the electron source. So electron source is nothing but, that is we are using the electricity. So moving of electron is known as electricity. So here also we are using the electron source is nothing but emission of electrons. So that's why here we using the electron source as electron gun with produce electron beam. So this is electron source or electron gun. So these electron source are produce electrons. So that is known as the moving of electrons or passes of electrons from the source to the anode, the disk structure like anode. So this is known as electron beam, while the electrons are transferring from electron source to anode in the form of beam. So that beams are known as electron beam. After here also, this is the closed surface region of the anode as a magnetic coil. So here also the electrons are transmitted with various directions and reaches the anode. So in this, the anode which allow only the electron beam in the form of holes. So then they passes and reaches the condenser aperture. So when the electrons move upon to the condenser aperture, so this condenser aperture condense two electrons into a single point and passes through the stem coils. So here the main purpose of the condenser aperture, which condense electrons into a single point and pass upon to the stem scan coils. So these stem scan coils which scans the signals, so that the image of the sample before being they reaches the specimen. So this is the base plate. Here we put the sample. So the sample is also known as a specimen. So here
Sir, condense and sir. Condense.
Condense means to conduct dissociation cheyadam nana. So here we various directions of electrons are pass upon the electron beam and reaches the anode. So here this closed surface, they cannot allow the electron beams. So only the center hole of the anode which is having a disc-like structure which allow passes through the electron upon to the condenser aperture. Here the condenser aperture, what they do means to condense the electrons into a single point. The number of electrons are reaches to the specimen. So only one electron can allow to passes to the stem scan coil. So that is known as condense. The bulk materials can be dissociated into lighter molecules. Then the lighter molecules are easily enter into the other regions. So that's why it is called as a condenser aperture. Condenser aperture is nothing but condense the electrons into a single point. Okay, is it clear, Nana? So when the electrons are pass upon the anode to the steam scan coils, so these are known as condenser lens. So these parts are known as condenser lens. So when they pass upon the they reaches the stem scan coils and they pass upon the specimen. So this is the particles, whatever it may be, we synthesized nanoparticle. So the is also known as a sample. So here we using the base plate and we put here the specimen. So here the specimen image can be detected by using the X-ray detector. Here by using the X-ray diffraction method to detect the image size, shape, that is known as a morphology of a sample can be detected by using the X-ray detector. So after that, so the sample detected by the X-ray detector, then the electron passes through the objective lens. So here the electrons are passes through the objective lens. Whenever we detect the specimen with the X-ray diffraction, after the electrons are moved and reaches the objective lens and passes through the objective aperture. So this is objective aperture when they passes upon to the objective aperture. So in this selected area aperture present in this TEM, here when the electrons are passes upon to the objective aperture, here we are having the selected area aperture present in this TEM. So this is the area, selected area aperture. So here this selected area aperture we use it to detect whatever it may be. We want a particular nanoparticle should only characterized, could image can be detected by selecting this selected area of aperture. So other nanoparticles, other signals can be eliminated or removed when the electrons are reaches to this selected area of the aperture. So then in this way the particle image can be detected. So other are restricted. So then are removed. So next the beam passes through the projector lens. So whatever it may be, we select the particles, particular particles image can only be detected by selecting this selected area aperture. After that the electrons are passes upon to the projector lens. Projector means which project, which expose or which like a screen display. So that is the projector lens. When the beam passes through the projector lens, which image occurs. So projector which display or viewing the image when the electrons are passed upon to the projector lens. So it is not helping for the detecting the image. So that which is help to display the viewing the image on the screen only, projector screen only. That is the use of projector lens. Whatever it may be, here we using. So then here the projector role play a major key role, whatever it may be we say. We cannot any help, internal help, which only uses for display of the formation of the image. So before being image and they reaches to the viewing screen, so here we using the detectors. So we study the detectors before being to the viewing screen. So here in the detectors, so there are two types, amplification and modulation takes place. Amplification and modulation takes place. So this is a bright field detectors, annular dark field detector. So by using these two detectors, we detect the image or size or shape of the nanoparticles before being viewing the screen. So what is meant by amplification? So amplification is nothing but increase the power of a signal. Amplification is nothing but to increases the power of a signal when the electrons are reaches to the specimen. So modulation is nothing but transmitted the type of signal received by the image. So the formation of image, whenever the electrons are transmitted to the image, so that image can be received the signals. So that is known as modulation. So this modulation and amplification. So here the formation of images in these two processes, we determine the image by using the bright field detector, which is used to determine the image when the amplification is occur. So dark field detector will use it to determine the detect the image when modulation takes place. So before viewing screen the image, we can use these type of two detectors to detect the signals, that means to detect the image of the nanoparticles. So after we using these two detectors, and then we reaches the viewing screen. After that we connect these viewing screen to the CCD camera, and they record the structures and signals whatever it may be. So we can collect. So this is the transition electron microscopy. We'll use it to detect the size and shape of the nanoparticles. So next we discuss the applications of nanoparticles. Or already we discussed applications of nanoparticles. So here we discuss the advantages and the disadvantages of these two microscopy techniques. So first we discuss the advantages and the disadvantages of scanning electron microscopy. So what are the advantages of scanning electron microscopy? So it gives a detailed 3D topological imaging. So topological means all the morphology they provide in the form of 3D structures. So and the versatile information garnered from the different detectors. So we are using different detectors. Already we discussed in the scanning electron microscopy. So we are using the black scatter detector, scanning coil detector, and secondary electron detector. So wherever absorption or reflection or formation of secondary electrons, so that information can be detected purely by this technique, which is an advantage. So next, this instrument works very fast. It's a rapid technique. So modern SEMS allow for the generation of data in the digital form. Nowadays, modifications or changes in the techniques. So where the digital, they provide the data in the form of a digital form. So most of SEM samples are required a minimum preparation of actions. So these are the some advantages of scanning electron microscopy. So next we discuss the disadvantages of scanning electron microscopy. So which is a very expensive. So that means cost is high and the instrument is a large. A special training is required to operate the SIM. So special training is required to operate the SIM. So the preparation of sample can result in artifacts. So artifacts means, so the preparation of sample can result in the form of image. So image is nothing but artifacts. So scanning electron microscopy carry a small risk of radiation. So exposures associated with the electrons that scattered from the belt to the sample surface. So while the electrons are reaching from the electron source to the sample specimen, so we face some risk. So there is the radiation risk. So these are the disadvantages of scanning electron microscopy. So next we discuss the advantages and the disadvantages of transition electron microscopy. So what are the advantages of transition electron microscopy? So transition electron microscopy offers the most powerful magnification, or potentially over 1 million times or more. So when we compare it with scanning electron microscopy, it's a rapid technique, and with the unlike very high resolution images can also be detected by using this transition electron microscopy. So next, these TEM have a wide range of applications and can be utilized in the variety of different scientific, educational, institutional fields. So these transmission electron microscopy were used in various industries they are using. So TEM provide information on component structures and images and high quality or detailed information. They provide the tanning transistor electron microscopy. So it's widely easy ability to yield information about the source, features, shape, size, and success information also they provide in detail. So they are easy to operate with a proper training. So it is easy to operate when we take the training. So that is the advantage of transistor electron microscopy. So next we see the disadvantages. So these are the some disadvantages of transmission electron microscopy. So TEM are large and very expensive. This also experiment is also required higher expensive. So laboratory preparation sample for enough for the synthesis characterization. So operation, so artifacts means the sample preparation. We prepared the samples. The samples will converted to images when we detect in the transition electron microscopy. That is the operation of artifacts from the sample preparation. So operation and analysis requires a special training. So here also we take some training to operating this instrument. Samples are limited to those that are electron transparent ability to the tolerate the vacuum chamber and small enough to fit in the chamber. So that means we use limited samples for the analyzing or detecting by using the TEM. So next, TEM is required special maintenance. So images are black and white images, and they provide the TEM when they detect the specimen. So TEM requires a constant keeping, including that the maintenance is important. So maintaining voltage or current to the electromagnetic coils and cooling water. So these are the some disadvantages while we using TEM for characterization of nanoparticles. So these are the two techniques we are discussing today class and their advantages and disadvantages. Niranjan?
చెప్పండి సార్.
ఏమైనా డౌట్స్ ఉంటే చెప్పండి మా, చాలా ఇంపార్టెంట్ సింపుల్ టాపిక్స్. నాకు మొబైల్ రెడీ కాగానే ఇది మీకు వాట్సాప్ లో షేర్ చేస్తా.
సరే సార్.
మీకు అర్థం కాకపోతే టాపిక్స్ నోట్ చేసుకోండి. రేపు క్లాస్ ఉండదు నాన్న, డే క్లాస్ కి మీరు నాకు ఇన్ఫార్మ్ చేయండి మీకు ఏ టాపిక్స్ అర్థం కావట్లేదు. సో ఆ టాపిక్స్ అన్ని నేను మళ్ళీ మీకు ఒకసారి రిపీటేషన్ చేస్తాను. ఏమ్మా?
సరే సార్.
నిరంజన్
సరే సార్, ఖచ్చితంగా చెప్తా.
టాపిక్స్ నోట్ చేసుకోండి, ఏం అర్థం కాలేదో మళ్ళీ నేను ఒకసారి మీకు నేను రివిజన్ చేస్తానా?
సరే సార్.
ఓకే అమ్మా.
మెయిల్కి పెట్టేస్తా సార్ అటెండెన్స్. 28 మెంబర్స్ ఉన్నారు ఇంచేపు.
పెట్టినాను. ఇంకేమైనా డౌట్స్ ఉంటే చెప్పండి. నిరంజన్
సార్ ఏం లేదు సార్.
చెప్పను సార్, చెప్పండి.
మీకు ఏమైనా డౌట్స్ ఉంటే చెప్పండి మా.
ఈ టాపిక్ అర్థమైంది సార్.
మీకు ఏ టాపిక్ అర్థం కాకుండా నోట్ చేసుకోండి, నాకు చెప్పండి, నేను మళ్ళీ రివిజన్ చేయడానికి రెడీగా ఉన్నా. నో ప్రాబ్లం నిరంజన్.
సరే సార్.
సరే నేనైతే ఓకే అమ్మా, లీవ్ చే.
ఓకే సార్.
పేరు వచ్చారు చూడండి, వెంకటేష్ వెయిటింగ్ లిస్ట్ లో ఉన్నాడు. ఆయన
నిన్న ఉన్నాడు. ఇంచేపు 28 మెంబర్స్ ఉన్నారు సార్. అప్పుడు స్నాప్ తీసాను.
చాలే నాన్న, చాలే.
సరే.
ఓకే బాయ్ మా. బాయ్ నాన్న.
బాయ్. సరే సార్.
బాయ్ సార్.
బాయ్ మా.
బాయ్ సార్.
బాయ్ నాన్న.